Okay, so hello everyone, 大家好. So what I wanted to talk about today is basically just to go through some of the things that happened in the Ethereum ecosystem and also in other blockchain ecosystems in the last maybe 6 to 12 months, and just go through some of the progress that we've seen and some of the things that we might talk about less, that at least I think are still kind of very meaningful and very important. Right, so we'll start off with proof of stake, and fortunately there was just a big long panel about proof of stake, so I'm sure people have already heard about proof of stake a lot. But, I mean, as the people in the panel said, the really nice thing about what's been happening in proof of stake in the last year is that it's finally moving from mostly being just an idea and it's just something that people are theoretically thinking about and theoretically wants to switch to in the future, to something that either people are building today or to something which is already launched today. Right, so the Cosmos mainnet launched earlier this year. Yay, it's running Tendermint, which is one of these kind of new generation proof of stake algorithms. Ethereum 2.0, this is the next major upgrade of the Ethereum blockchain that will include proof of stake and will also include scalability through sharding. And this has been under development for years, but it's now basically only months away from being launched, right? So earlier in September, in Toronto, we had this workshop where the engineering teams that are building the Ethereum 2.0 clients, there's 7 different teams, all came together in Toronto, and they basically got all of their clients to kind of fully implement the latest specification and got all of the clients to talk to each other, to process each other's blocks, and to kind of all form a small network together. So there's all of the people looking at the network, the people are happy, there's a screenshot of the different clients together. So it's been a lot of progress. Now, Ethereum 2.0 obviously has not launched yet, but the interesting thing is that it's already close enough to being launched that we're not just looking at proof of stake as a theoretical idea. We're not just looking at how we're changing how the consensus works, making blockchains much more efficient. We also have a chance to look at kind of some of the actual challenges that we see. So challenges are not a bad thing. Challenges are inevitable in any new system, and they're always going to happen when you finally go from a system only existing on paper to a system existing in reality. So in the case of the Cosmos network, for example, there was this kind of interesting economic property that we saw where basically validators, so people that you can delegate your coins to, were starting to kind of compete with each other on price and starting to try to charge lower fees with each other, and people in the Cosmos community started to become unhappy because as the price competition became more and more fierce, it started to become not practical for some of the smaller validators to stay on the network, and so people were afraid of market concentration. So this is one example of a kind of problem that developers of all proof of stake protocols need to be concerned about. Staking centralization, but it's still interesting that 2 years ago you could only try to think about this theoretically, and now you can try to see, well, to what extent does this exist on live networks. Now, in the case of Ethereum, Ethereum 2.0 has not launched yet, but the specification is basically finalized, and so people have been starting to make these these kind of third-party analyses of, like, is it going to be profitable to run a node? Under what conditions is it profitable? How do we model hardware costs? How do we look at what the revenues are, what the costs are? Under what conditions people will be willing to participate? And people have already started giving feedback that has already kind of influenced some of the details in the algorithm. So it's gotten to the point where the protocols are mature enough that we're seeing challenges at this level of detail. Now, scalability. Scalability has really improved quite a lot in the last year. So there's two kinds of scalability solutions. There are layer 1 scalability solutions and layer 2 scalability solutions. In the case of Ethereum, there's sharding, and sharding is, once again, finally now under development, and we're hoping to start seeing test networks for sharding fairly soon. But there's also layer 2 scaling solutions. Right? And for layer 2 scaling solutions, we've actually seen several of them get to the point where there is some, at least kind of a minimal demo version of them running on the Ethereum mainnet. So the first two, Start Plasma and ZK Rollup, when I was here on a panel earlier this afternoon, I mentioned general purpose zero knowledge proofs, SNARKs, STARKs, and these are very new technology. Right? 3 years ago, STARKs did not exist. 6 years ago, SNARKs did not exist. And now what we're seeing is scalability solutions that use SNARKs and STARKs to basically prove that large sets of transactions are valid at the same time. And so the reasons why this makes scalability better is that instead of a large set of transactions having to be verified by everyone on the blockchain, this large set of transactions can just be verified by one node that generates a proof. The proof can be published in the blockchain, and then on the blockchain there's a much shorter and simpler proof that every node on the blockchain can verify. In the case of Ethereum, for example, the current Ethereum network can process a maximum of about 20 to 25 transactions per second. Any of these roll-up schemes, theoretically right now, can process up to about 700 per second if everyone starts using it on the Ethereum main network. And in a couple of months, we're planning to have the Istanbul hard fork. And after this, that number will actually go up to about 3,000. Right? So these are things that do exist to the extent that there are versions that you actually can run and use on either a testnet or the Ethereum main network right now. So scalability, right? There's a lot of progress on scalability. But what about applications? Now, I'm not necessarily going to talk too much about kind of very narrow and very specific applications, but I do want to talk about some things closer to the user that I care about. So we'll start with wallets, right? So wallets are the way that any user interacts with the blockchain. And wallets are the way that a user authenticates themselves to the blockchain. When we talk about blockchain applications, we talk about these nice properties that a system is decentralized, it does not depend on third-party trust. You can verify that if some action happens on the blockchain, you know who authorized that action, you know who did it. But all of these properties depend on some kind of mechanism for authenticating who is a user. Now, for the first few years of kind of cryptocurrencies in history, a wallet was just a private key, right? So a wallet basically is just this piece of software that holds one cryptographic key, and this cryptographic key is used to digitally sign every message. Now, the problem with one cryptographic key is that one cryptographic key is very easy to lose. right? This is a article I wrote for Bitcoin Magazine about 7 years ago. The evil Java application. So basically, this is one example of something that happened to someone who had a wallet where it was just one private key and they controlled the private key, but then they installed an application. And this application basically started secretly recording the user's keystrokes, and it got the user's password, and then decrypted the user's wallet, and basically took all of the user's coins and sent them off to a hacker. So things like this can happen, right? Security issues on computers exist, and so holding your coins yourself can be risky. Now, the other solution is, of course, centralized, right? If you do not trust yourself, hold all of your coins in a centralized wallet, hold all of your coins in an exchange. But this, as we know, also has big security risks. So on my Bitcoin, this is probably the first centralized wallet that existed in Bitcoin. And after 2 months, it got hacked. Actually, we don't know if it got hacked. Maybe the owners decided to run away with the money. We have no idea. Right? So, and if the user having one private key and centralized storage of coins and of accounts are both dangerous. So what's the alternative? So there's recently been this kind of growing movement toward something that I call smart wallets. And a smart wallet basically means instead of your coins being controlled by a key, your coins are controlled by a smart contract. And this smart contract can enforce some pretty complicated conditions about how coins from your account can be spent. So for example, you can have multi-sig. So multi-sig says you have 3 keys and any 2 of those keys can be used to spend the funds. And 3 different keys might be on 3 different devices. One could be your computer, a second could be your phone, a third could be a piece of paper that you store at home. A third could even be a piece of paper stored by your friend. There's also this concept of a social account recovery, and the idea here is that you have an account and there is one key that can normally do things on behalf of the account. But if this key gets hacked, or if this key gets lost, then there exists a kind of set of users that can come together. And this could be institutions, this could be 5 of your friends. There's different ways to set this up. And this kind of larger set of keys can come together and they can agree to change the main key of your account to something else. So if you lose your key, they can recover it, and if your key gets hacked, they can stop the attack. The HTC Exodus blockchain phone has a social account recovery scheme. Argent Wallet has this guardian mechanism, which is also a social recovery scheme. So this is these options did not exist 1 year ago, and now there are several options that you can choose from, and with every month they are getting better. Right? So these are 2 projects, but I know of at least 2 other projects that are trying to do the same thing. So that's wallets, decentralized exchanges. So who here tried trading tokens on a decentralized exchange in 2017? So the experience probably was not very good, right? It was complicated. You had often the interface would not work. You had to send like 5 transactions to make a trade. Now, who here has used a Uniswap in 2019? More people. Right? Uniswap is easier to use, right? Much easier. So, your ability to just trade one asset for another asset has gotten much simpler. And the other nice thing about things like Uniswap is that they're not just for users. You can also have applications that just automatically talk to Uniswap in order to trade coins. So Decentralized exchanges, there's even projects that are starting to make decentralized exchanges to go across different chains. So this is in Sumo Auctions, it's a decentralized exchange that's basically an auction going between Bitcoin and Ethereum. So finally being able to go between the world's two largest cryptocurrency ecosystems without needing to go through a centralized intermediary. So what does this give us, right? So decentralized exchanges make it much easier to build applications that kind of work with many different assets, reduce the risk of hacks. So there's no kind of single entity that you can just steal $84 million of coins from. Permissionless, anyone can participate. Once one of these, a decentralized exchange is set up, it's guaranteed to continue existing, and so it's something that other developers can feel safe building on top of. And the existence of decentralized exchanges really helps to mitigate kind of the large power that centralized exchanges have in the ecosystem. So, a lot of progress. Privacy. So I mentioned in the panel earlier today already that there has been a huge amount of progress in general purpose zero-knowledge proofs, but there has also been a large amount of progress in applications using general purpose zero-knowledge proofs. So the Ethereum mainnet is now starting to have some form of on-chain privacy solution. So there's Tornado.cash, there's something called Hopper, which is under development. There was another project called Semaphore that was recently released. And basically, it's using ZK snarks to do kind of the same thing that Zcash does as a second layer on top of Ethereum. Now, this is only the first step, but I already know that there's other and even more powerful projects that are already under development and will continue to be released over the next year. DAOs. We have seen a lot of progress in DAOs over the last year. We've seen MakerDAO, Moloch DAO for grants in Ethereum, Aragon, and these DAOs are used for lots of purposes. So, for example, grants, charities, funding open source development, governing kind of parameters in decentralized applications. And so, DAOs are naturally risky, and as we know, a DAO kind of broke in a very big and a terrible way 3 years ago. But the more recent projects, they're really trying harder to pay more attention to security, make sure that everything is audited, everything is formally verified, and so far, it does look like this newer generation of DAOs has learned from the lessons of the original one, and it is starting to create things that actually are more meaningful. Experiments in public goods funding. So there's this platform called Gitcoin Grants, and what it's done is it's basically used a kind of donation matching mechanism that we now call quadratic funding that Glenn Wild and Zoe Hitzig and I came up with last year. And it's trying to use this basically to create this kind of decentralized community-driven mechanism for allocating funding toward public projects that benefit the Ethereum ecosystem. And Gitcoin Grants has had 3 rounds now, and it seems to actually be working quite well. So there are problems, of course. So for example, one of the big problems in DAOs that we've started to see is bribery and collusion. So about 6 months ago, I wrote a blog post about this. It's on Vitalik.ca. The title is On Collusion. And I basically kind of criticized things like on-chain blockchain governance and most kinds of on-chain coin voting, basically because these mechanisms are just structured in ways that make it very easy for people with large amounts of coins to basically kind of coordinate with each other and support each other, bribe each other to make votes for each other and kind of get much better returns inside the system than everyone else. And for Moloch DAO, there is someone at a recent hackathon released this kind of wonderful project called Sellout DAO, which is really fun. It's this very simple smart contract where what the smart contract does is it just says, if you have a voting share of Moloch DAO, then you can transfer your share of Moloch DAO into this contract, and then basically anyone can buy your vote. So it's taking this kind of vulnerability of coin voting that anyone can buy your vote, and it's just creating this really simple interface, making it really easy to do, and just showing the world, you know, hey, this problem exists, let's try to come up with ways to solve it. We are coming up with ways to solve it. So this is a blog post, a post on ETH Research that I made about 4 months ago, where I basically advocate kind of using a combination of encryption and zero-knowledge proofs and eventually multi-party computation to make a kind of a voting infrastructure that could be used for DAOs, could be used in other use cases, that allows you to basically run these votes in such a way that you cannot, but no one sees how anyone else participated. And so the theory is that if no one else sees how you participated, then like you can't do bribes, you can't kind of maintain collusion. Like you basically get like the economic model that we wanted from the start, where the only result from, or the only thing that happens as a consequence of some choice you make in the system's governance is the consequence that is defined inside of the protocol, right? Like there are no unexpected side games. And so this is actually something that the Ethereum Foundation's Zero Knowledge team is also in the process of developing. And this could be used for things like securing voting schemes, could be used to make better DAOs, along with many other things. Improvements in kind of fundraising. So 2 years ago we saw ICOs. ICOs are great, ICOs are also terrible. And the thought that I had is, well, why not use smart contracts to make better ICOs in such a way that basically you reduce the incentive misalignment, right? So instead of the money going to a developer immediately, where the developer can just run away with the money, you send money into a smart contract, and the smart contract has some rules by which it slowly releases money to the developer over time. And this is a DAICO, a design that I created 1.5 years ago. There's also this newer design that kind of very cleverly uses kind of DeFi and compound interest rates called a public interest project. I encourage everyone to kind of look at the, read up on this online. A lot of kind of very interesting ideas for how, like basically we can use blockchain technology and smart contracts themselves to solve some of the real problems that the blockchain industry has been having. So these are some things that have happened, right? So things to look forward to. One thing that we have been getting better at, but we can get even better at, I think, is better and more trustworthy protocols. So a lot of decentralized finance applications, a lot of other applications on blockchains rely on data from the outside world. And we need trustworthy sources of data from the outside world. So I know there's projects that are trying to do this, but they are continuing to grow, and at some points they will become much more useful. Proof of stake and sharding on Ethereum I'm actually launching. Smart wallets becoming more popular. I want, 2 years from now, for almost everyone using Ethereum to be using Ethereum through a smart contract wallet that provides much higher security than a single private key. Smart contracts for fundraising, smart contracts for other use cases. Hybrid decentralized exchanges, so centralized exchanges that use things like ZK snarks and ZK starks and Plasma to improve their security. And in general, I'm hoping to see basically more things like Uniswap, right? Decentralized applications that work even better than centralized alternatives. And I think that we're getting closer and closer to finally getting there. Thank you.